So we take the original quantity, and then we have to look up some kind of conversion factor from grams to ounces, and then we end up with our desired quantity. Let's see. So we have a lot of conversion factors here. There's some on Alex. Okay, so just get familiar with the ones that are in Alex so you don't have to write those down. So one that you are going to need is 1 milliliter is the same as 1 centimeter cubed. This one is not in Alex. So either you need to remember this, or you could write it on your note card for your test. But 1 milliliter is the same as 1 centimeter cubed. It's 1 to 1. Okay. So back to our grams to ounces. If I know that there's 28.3 grams in 1 ounce, then I can use this as a fraction, okay? That's a ratio. So I could say 28.3 grams in 1 ounce, or I could say for 1 ounce, that's 28.3 grams. So I can write it either way. I need to decide which one to use. So what conversion factor are we going to use? What version? When we go from 5 grams to ounces. Will we have grams on the top or the bottom? So let's try that. So if we put the one with grams, if we put grams on the top, grams per ounce, what will our units be at the end? So our units will tell us what to do. Our units, this is saying grams times grams divided by ounces. If we do it like this, we will get grams squared over ounces. So all we have to do is we just flip it, okay? So we need ounces on the top, on grams on the bottom. So now we have a grams on the bottom, grams on the top, and we'll end up with ounces. So another way to think about this is, whatever I end up with, if I want to end up with ounces, that needs to go on the top of my conversion factor. Okay? Does that help? I think that helps me to keep track. Okay. Or whatever I start with needs to go on the bottom so it will cancel. Okay. Oh, I had that up there. Okay, so we talked about that. It needs to be ounces on the top so we end up with ounces, and so that grams cancels with grams. And then if we multiply this through, we get our answer. And then we need to make sure, even on calculations that aren't asking about significant figures, we need to keep track of them. Okay, so this has 1, this has 1, this has 3. We can only have 1 significant digit at the end. This only has 1 significant digit. Okay, questions so far? We're doing all right? Okay. So let's do this one. So if we have 325 milligrams, what would be our conversion factor? Let's just write something like, how many milligrams are in a gram? Or like, how many grams are in a milligram? Something like that. You guys know? Okay, so gram, that's our conversion factor, over milligram. Good, because now milligrams are going to cancel, and we'll end up with grams. We want grams. So do you guys know how many milligrams are in a gram? Yes, so there's a few different ways we could write it. We can either write there's 1,000 milligrams for 1 gram, or I think we talked about last time, it's like 0.001 grams for 1 milligram. So you can write it either way. Okay, and then we would divide. This ends up just moving the decimal 3 times. 1, 2, 3. Or you could type it in, that would be the same thing. So 325 milligrams is the same number as 0.325 grams. Okay, we're doing all right? Okay, I don't want to do a whole bunch of practice. How do you guys feel about this? So what I realized is that the more time I can give you an Alex, the better that is. So do you guys feel comfortable enough with this? Or do you want to do another example? You feel okay? Okay. All right. The next thing that we need to talk about is temperature. How do we define temperature? Good. In our class, we're going to mostly talk about Celsius, good, or Kelvin. So when we measure something in Celsius or we're measuring something in Kelvin, what is that measuring? What are we talking about?
Why are you this bad?
What is temperature?
Wait, what was the question?
How do you define temperature? What is temperature? What are we measuring? Yeah.
How hot or cold something is?
Okay, how hot or cold something is. Good, yeah. Good. How hot or something cold. What were you saying? Something else? No? Okay. You don't want to share with us your knowledge?
Tells you how fast the atom is.
Good. Yes, yep, and that on the molecular level is how fast or slow something's the atoms are moving. The atoms or molecules. Good, thank you. Okay, so we talked about Celsius and Kelvin. Do you guys know any others? Fahrenheit, good. Okay. So these are the most common ones. There's also one called Rankine, which is like the absolute scale for Fahrenheit. But we are going to stick with Celsius and Kelvin. Okay, so I like this picture. It kind of orients us with what these normal temperatures are. So normal body temperature is about 98.6 if you're measuring it in Fahrenheit. Celsius is about 37 and Kelvin is 310. I worked with a lot of people from not the United States when I was doing my PhD, and all these people from like Canada and other places in the world would always talk about how cold it is outside in Celsius, and I had no idea what they're talking about. So I think the more comfortable, like the more often you use these scales, the more comfortable you start getting with them. Yeah?
So why don't we only use like one of them, like Celsius, 0?
Because we are in the United States. I'm not sure. So it's like, why are we measuring our roads in miles? And yeah, so maybe if you become a senator one day, you can change it. You can change it for us and make it make more sense. Yes. But for now, this is kind of what we're familiar with. So, and we talked about water. Water freezes at 0. It boils at 100. And you guys know that Kelvin is based on absolute 0. So at absolute 0 Kelvin, then our molecules are not moving. Our atoms are not moving. Okay, that's pretty hard to reach.
Have we ever reached absolute 0?
I don't think so. I was listening. I think it was a book. They were talking about how they were shooting lasers at atoms to make them slow down. So they would like move and they would like slow them down. And they got really, really close. It was like 0.0000 something. But so they can get really close, but I don't think they've ever made it to absolute 0. Yeah, I think it was a university in Colorado that.
What happened if something is absolute 0? Is it just cold?
Yeah, and some interesting things happen. So with the electron energy levels, I think they like all like meld together. So that's pretty interesting to look into. I can't remember what atom it was that this group was looking at. I think it was, I can't remember. But it became like one big blob of atom. at really low temperatures because of the way the electrons are interacting. I don't understand all of that, but it was pretty interesting to listen about. So, yeah, that's an interesting topic, absolute zero. Okay. Yes, a lot chilly. Other questions or thoughts? Okay. So we are going to mostly need to convert between Celsius and Kelvin. This conversion is not in Alex. So this one is you have to memorize it or you have to write it on your note card. Okay. So if we are starting with Celsius, we just add 273.15. Okay, to our Celsius, and then we will get Kelvin. If we have Kelvin, then we just subtract that number. We subtract 273.15 and we get Celsius. So when we do this process with significant figures, we just need to figure out where did we start. If we started with 3 sig figs here, this is a definition. This doesn't count against our sig figs. Okay, we just look at, oh, this had 0 decimal places, so I get to end up with 0 decimal places. Okay, or sig figs. Okay, we just go by sig figs of the number we started with. Okay, so hopefully you've got that down. So basically we just have to remember one number, 273.15, and then we have to decide we're going to Kelvin, we need to get bigger, we're going Celsius, we need to get smaller. Okay. So, a lot of people when you talk to them about room temperature, they talk about 25 degrees Celsius. What is that in Kelvin? 298.15. So how did you do that?
Add 25 to 73.
And what did you get?
298.
298.15?
Yeah.
All right, and then how many sig figs does this have? 2. So we can only have 2. So what are we going to do? We can only keep 2 sig figs. So yeah, we're going to... Good. So this is going to be 300 Kelvin, but this is ambiguous. We don't know how many it has. So we're going to do this, 3.0 times 10 to the 2 Kelvin. Then we know for sure we have 2 sig figs. Yep. So no one really does this in real life, but Alex, I'm pretty sure Alex is going to ask you to do it like that. In real life, you probably just put 300. Okay. Questions? But do you have a thought?
Just now, just ask for sure decimal points.
Oh, okay. If Alex is specifying, then that's good. Yeah. Just follow that. Okay. Great. All right. What is happening here with our 2 sodas? They're both sodas.
Are they like full?
They're both full. They're both closed.
Oh, one of them shaking up.
One's shaking up.
So there's
One's
bubbles
diet,
and
yeah.
stuff don't float.
One's diet, the other's not. It does say this one says diet. This one says, I don't know, regular.
Plastic.
So how would that affect what's going on? Which one's floating? The diet. The regular is sinking.
The sugar may keep floating.
The sugar may keep float. So it looks like, what is different about diet and classic? You're saying sugar. Which one has sugar? Okay, so this one has sugar. This one has, I don't know what it has in it. Why does one float and why does the other one not float?
It's the carbonations and the airs, the bubbles.
The bubbles? You think that they have different carbonations?
Yep. I have no idea what drinks are.
More
Oh,
sugar,
right, yeah. We shouldn't ask you, you don't do soda.
more
You're
sugar
saying
weighs more.
sugar, okay.
Less sugar.
So we have this shape, right? So you're saying this one has more sugar in the same shape. This one has the same shape, but it maybe has less sugar, less stuff inside. Okay, what do you guys know what that's called? Good, yeah, that's density. Good.
Taylor, you have a mouth that can communicate words to the world.
Keep talking to him.
Oh, he's gonna know all the answers.
And you just tell me, sounds right.
Okay, you're gonna be the microphone for Taylor. Okay. So let's look at these. This is like an Alex question. So you have to tell me which one has a larger density. That's a scale. This part is the scale. This is my very crude scale. Okay, I agree with you. Why?
Because the scale is tipping in its favor.
Okay, the scale is tipping in its favor. So it has more mass.
Mass.
Okay, and they're the same shape. We have to check two things. They're the same shape. If one has more mass, it has a bigger density. Okay, next one. Which one has a larger density? Okay, good. Can you explain to us why?
So it's still heavier,
Uh-huh.
but it's in a smaller shape.
Good, smaller shape and heavier.
Yeah.
So more dense, good. How about this one? So some of us are saying the right one. Okay, so we know that the right one weighs more because of the scale. It could be equal why?
Because even though that one has more mass, I guess, the left one's smaller. So its density is, yeah.
Okay, so what if we imagine we took like some cheese, same cheese, and we put a bigger piece of cheese and a smaller piece of cheese. They're the same thing, but the bigger piece of cheese would just weigh more, it would have more mass. Okay? Or the other thing that could happen is, what if this is just really big, right? It has a mass. It has a bigger mass, but it has a smaller volume, a bigger volume, so then the density could still be less here, right? This one, we don't know the mass, we don't know a number. We don't know the actual volume. So we can't say for sure if either of them is more dense or less dense because we don't have the numbers. All we know is the mass. Yeah?
So like if the big one's like wood, and the little one's metal, would the metal be more dense than the
Yes, yep. So maybe we have a wooden log that's bigger, so it weighs more, but the metal piece is, yes, is more dense. Yes. Good. Okay, does that make sense? I think this is the trickiest problem on Alex that I've seen. There's one more tricky one that I've seen is when they'll put like 2 blocks on the scale. And you have to think through, what if there's 2 blocks on the scale? Okay, so be ready for that one too. But I think if you can think through this type, you'll be okay. This is the hardest one. All right, this is our formula for density, and we've kind of talked through it in our heads. It's just the mass divided by the volume. Okay. And in our chemistry class, when we report density, it should be in grams per milliliter or grams per cubic centimeter. So centimeters cubed or cc. And remember, how many milliliters in a cubic centimeter? Yeah, good. 1 to 1. 1 milliliter for 1 cubic centimeter. Very good. Okay, I think I have a practice one on here. Let's do, which one should we do? Should we do 2 or 3? Which one do you want to do? 2? Okay, 2. And then we will just do 1. So go ahead and try 2 for a minute, and then we will do the rest of it. We'll try it together. This one. So I heard that we have to convert this into grams. So how do we do that? We have 45 kilograms. Okay, times by 1,000. This should be milliliters. Sorry.
Yeah, I had no
Grams per kilogram. So kilograms cancels. We get 45,000 grams. This looks like a weird problem. Okay, and then this is milliliters, I guess. I'm not sure what this is. Maybe it's supposed to be liters. I'll fix it. We'll do it like it is now in milliliters. So grams per milliliter. What did you guys get here? 806.45. All right, and then this is division. So we go by least number of sig figs. So then this one has 3, this one has 2. We have to just keep 2, so this would be 810. Oops. And so then we would have to do like, either Alex is going to tell us how many, or we would have to do 1, 2. 8.1 times 10 to the 2. And grams per milliliter. I will fix this. Thanks for doing that. Now I know what's wrong, so I'll fix that. I just have 2 masses. That's not make sense. Okay. Let's see. Is this? Oh, I do. Okay. Before you start on something else, let's talk about the lab really quick. So I think I've checked out everyone a lab book. So I just heard, I'm still excited.
I ordered one of those.
You did?
Yeah.
Okay.
Because I didn't want to write everything.
Okay, perfect. So this book here on page 1, up at the top, this is the first experiment we're going to do. We're going to do this on Friday. This one doesn't use any chemicals, so if you forget to do the pre-lab before class, that's okay. But for all the other experiments, you have to do the pre-lab before you come to class, so that you can go right into the lab. So I think that's a good thing to practice. I will send a remind email to remind you. But going forward, you have to do the pre-lab before you come to the class so that you can be ready for class. Okay, so there's the pre-lab. The questions relate to this introduction material for the lab. So the first question asks about safety. If you go to a lab where we use chemicals and look through, there's these like, oh, this is how you dispose of. There's like instructions on disposal. There's instructions on, oh, this is, let's find the safety one. There's not safety one. Some of them have like a little triangle, oh, there's one that says safety alert. So when it's asking you, the first 2 questions are always going to be, are there any safety things for this lab? Is there anything that you need to dispose of? For lab 1, there's not, so you just put no, you didn't blank, that's fine. And then the rest of the questions should have been answered in the introduction. It should talk through all of the questions, but you can also ask me on these pre-lab questions, or any lab questions, or any data. Okay, so if you have questions on that. This lab, what I'm looking for mostly is, do you have the right number of sig figs? Did you write down the right number of decimal places with ruler A or ruler B? Okay. And then we have our little sheet. Oops, where is that? Here it is. And I printed you one of these off. Okay. When you're answering your lab questions, you can just write on paper. So you can be like 1, and then answer it. 2, and then answer it. And then I know the questions. I can look it up. Okay. Something that I care about is that it's in order, okay? So when you turn your pre-lab in and you use like 6 pages, I don't know, make sure your pre-lab is like in the order that it goes in, okay? And then I also care that it's a PDF. Make sure you're submitting this as a PDF. You can put it in like a Google Doc and then download it as a PDF and then upload it. Or you can take a picture and then upload that as a PDF. You might have to convert it into a PDF, but I care that it's a PDF, yes.
So you want it done online, not on paper?
I want it submitted through Canvas.
Okay.
Yes. But most people will do it on paper, I think, and then submit it on Canvas. Okay, and then these tables, remember you can't write in my book, but you can write in, you could like draw the tables out, you could do this in Google Sheets, you could do it in Excel, and then you can write your tables, your own tables, okay? And then this is the post-lab question. So once you're done with the lab, this is the post-lab questions. I need to know like 1, and then I'm picking A, and then Y. Okay. Questions on the lab. Does that make sense? Where do we turn in our labs?
On the lab campus.
On the lab canvas, on the 1115. Good.
Wait, do we do pre-labs?
Pre-labs will also go on 1115.
Oh.
Okay, good. Okay, questions on lab. All right, let me pull up the schedule one more time and we'll talk about the due dates. Because it is kind of confusing. So before you come to a lab, so like next time, before you go into the lab to do lab 2, you'll have to show me that you've done the pre-lab. So you can turn it in and I can check, or you can just show me like, look, I have done the pre-lab, and then I'll let you go into the lab. The lab and the post-lab are going to be due the next class period. And I put quotes. It's going to be open, it'll be due. This is when I will start grading them. So if you turn it in, I will start grading them. So when you come back on Tuesday, it will be, so next class period.
Wednesday.
I will figure that out. Yeah, Wednesday. It will be, I put it on B day because we have this class. There's a class A day and B day. So I put it on B day. So you guys have an extra day. So it'll be due on the B day. That just means I'm going to start grading it. And then it will be open. So if I grade your paper and you decide, oh, I'm going to fix those significant digits, I'm going to remeasure this. I'm going to re-add these and make it make sense. You have until the next lab to keep turning it in, to keep correcting it. I will keep grading it. And then it will close the day before lab 2. Does that make sense? It is kind of confusing. But yeah, so.
What's the average chapter 1A?
This is that pre-assignment. So you do your knowledge check and then there's this pre-assignment. And then there's chapter 1. I can pull it up on my end too. Here we go. So if you go to this hamburger, it'll tell you what assignments you should be working on. So here, this is this review chapter 1A. And then the next assignment is going to be due next Tuesday, that's chapter 1. Yeah.
So if I did them all right on my first Alex,
On the knowledge
it-
check,
it wouldn't do it.
yeah, if you got through it on the knowledge check and you didn't like skip the knowledge check, then it would give you points for what you've got already. Okay, other questions on the Alex? Okay. All right, so now we get out of class, I think at the 30. So we've got about 35 minutes. So I would work on the lab, the pre-lab. I would make sure, probably I would make sure that this assignment is done, this review, chapter 1A. I would make sure that's done. And then I would probably do some of this chapter 1 assignment, make sure you're making progress on that. And then I would probably work on the lab, the pre-lab. That would take stuff.
Here's 26 plus questions.
I'm looking at this question, so I'm almost there, understanding this.